Hello, good afternoon. Hello and welcome to the sessions on territory, urbanism and the Anthropocene. This semester series focused on the notion of ecology. This is our second session this semester, organized jointly by the professorship Marc Angelil and myself, Milica Topalovic, with the help of Sascha Roesler, Hans Hortig, and Jörg Stovins, today with the colleague Alex behind the camera. To give a few words of a context, this semester, together with our guests, we are exploring the ways in which Anthropocene, understood as both a scientific and political category, shapes the fields of architecture and urbanism, our practices, our theoretical discourses, and our education. We would like to use this platform to debate and to understand better how the various complex socio-ecological priorities that we continuously debate that are implicated under the notion of Anthropocene, from, let's say, reducing CO2 emissions to the resource and energy consumption. How will such priorities shape architecture and urbanism and design agency in a more general sense? And herein, under architecture and urbanism, we actually understand a wider range of practices from design at various scales, from the building design to territorial design. We understand research practices. We also understand different spatial practices, including artistic practices. We understand also action research and urban activism in this under these let's say extended picture of our disciplines. We also have a very specific understanding of the notion of the urban. This is the site, to say so, of our investigation. And we understand the urban in the extended sense, in relation, for instance, to the notions of planetary urbanization and extended urbanization. So this understanding involves a broadening of perspective from cities to urbanizing territories, and even to the planet as a whole. So understanding of the urban in an extended sense as the site of Anthropocene transformations. So in this context, we are asking ourselves how to conceive of the design agency, not only as agency of urban transformation, but also agency that operates within the Earth systems. We would like to, in particular in this auditorium at the ETH, to understand also how, under these priorities, we might shift and reinvent, let's say, our educational concepts, our educational practices and the curricula. And this is a series that we have initiated last semester. In total, we will have around 10 speakers. They have ranged from those that spoke about let's say, new theoretical fields that are implicated in these discussions, such as Jason Moore, foremost political ecologist, or Nikos Katsikis, to practitioners such as, for instance, Sandra Bartoli and Uz in the last semester. So, therefore, it is my great pleasure to welcome this afternoon Dr. Sascha Roesler, who will present the talk, Architecture and Urban Climates. Sascha is an architect and theorist working at the intersection of architecture, ethnography, and science and technology studies. Since 2016, he is the Swiss National Science Foundation Professor of Architecture and Theory at the Academy of Architecture in Mendrisio. He is setting up a new research field on passive climate control in the city, and within that framework, he leads a group of doctoral and postdoctoral researchers. With the underlying rationale of the city as political ecology, his project combines microscale investigations of local thermal practices, the use of energy commons, and the political regulations of climate control. Sascha is the author of several outstanding books and publications, and here I have the most recent one, Anthology, the Urban Microclimate as Artifact, published last year. This book expands existing approaches from applied climatology and building science by emphasizing the man-made character of urban microclimates. I would also like to mention that Sascha's work is fascinating and interdisciplinary in the ways that you will be, I'm sure, surprised and thrilled about. He is also the recipient of Swiss Art Award in Architecture. And after Sascha's talk, I will invite as respondent Alice Hertzog, but Alice will be introduced afterwards, so please help me to welcome Sascha Roesler.
So thank you so much. Welcome. Thank you, Milica, for this very kind introduction. It's really a pleasure to be here and having the opportunity to talk in the frame of this amazing series of lectures. Preparing my talk today, I reminded me on a talk I gave in this particular lecture hall 5 years ago. It was entitled Man-Made Weather. You can see the poster on the left, and obviously there is a certain continuity in my interests in the last years, as you can see. So we are mainly concerned with questions of microclimate, city climate phenomena, and different forms of passive climate control, and how it might affect architecture. So what I'm going to present this afternoon is kind of an introductory lecture into the notion of city climate from the perspective of architecture, relying on Michel Foucault's idea of a critical archaeology of knowledge. As motivating questions of this lecture, I'd like to mention the following two. Firstly, what is an architectural approach to city climate phenomena? And secondly, is there a genuine architectural perspective, or should we better leave this topic to, let's say, scientists or urban planners? The content of this lecture evolved over the course of the last few years in Singapore and in Mendrisio. In essence, it is an outcome of our current research project on passive climate control and the city, funded by the Swiss National Science Foundation. One of the critical implications of this research project is to conceive of the city as the new indoor environment of contemporary societies. While 20th century architecture learned to control the climate of a building, the architecture of the 21st century needs to learn to cope with the climate of cities. There's a need for a new focus and scale for saving energy, challenging the current architectural obsession with producing energy-saving buildings. The notion of the city as indoor environment allows, as you will see, to rethink climate control, a key concern of the discipline of architecture, through the lens of city climate phenomena. My presentation this afternoon has 4 parts. I will start with some epistemological remarks on today's widespread dichotomical thinking of inside and outside areas, followed by an introduction into the intellectual history to conceive entire cities and not buildings anymore as indoor entities. In the third step, I will highlight energy concerns as design concerns by presenting some of the components of a theory of practice aiming at controlling the climate of cities by architectural means. In the last part of my lecture, I will present some of the case studies of our new ontology that relink deliberately indoor and outdoor areas. I start with the first part, inside, outside. In his seminal book, The Poetics of Space, the philosopher Gaston Bachelard scrutinizes the fundamental significance of the terms inside and outside for our thinking. Bachelard speaks of a dialectic of division that outside and inside form, and he criticizes, quote, the obvious geometry of which blinds us as soon as we bring it into play in metaphorical domains. It has the sharpness of dialectics of yes and no, which decides everything, end of quote. Bachelard distrusts the real-world relevance of the divide, and he recommends to search for what might be beyond this dichotomy. Bachelard's reflections are of great relevance for a critical re-evaluation of our contemporary thermal concepts, presupposing a sharp division of outside and inside conditions. To conceive thermal environments through this dichotomy is a widespread but more and more contested narrative of 20th century architecture. Rather than having simply blurred the boundaries between inside and outside, 20th century architecture has set up this dichotomy systematically in the built environment by means of its concepts of comfort. Due to its endemic overheating, the early glass architecture of modernity was even a driver for the spread of air conditioning and thus an incentive for this dichotomy. Along with the mechanization of the residential sector, a modern metaphysical thinking of inside and outside has taken command, which today coins our most advanced concepts of sustainability in architecture. Until the emergence of modern comfort, buildings have always been linked to the surrounding environment thermally. Microclimates of varying degrees formed smooth and incremental transitions between inside and outside. Thermal continuity and diversity, and not the dichotomy of air-conditioned interior and non-conditioned exterior, formed the rule of human history until the middle of the 20th century. As research in comfort restricted itself on stabilizing and homogenizing the thermal conditions inside of the buildings, the rich architectural tradition of varying microclimates hasn't been cultivated any longer. In the residential sector, great thermal uniformity has been set up at all costs and with enormous energy expenditure. The former differentiation of more or less heated zones in the house has been abandoned in favor of a simple, unified solution via central heating and air conditioning. The modern vision of a constant, uniform temperature in all situations, seasons, and climates still becomes reality today. However, the other side of the technical perpetuation of a thermal dichotomy is global warming. The building sector contributes substantially via its heating and cooling practices, as the environmental sociologist Elisabeth Schoaf has noted in 2009, to the global phenomenon of climate change. Quote, the resources consumed in managing the indoor environment are, ironically, one of the more significant causes of outdoor environmental change, end of quote. This applies particularly to the climate of cities that are increasingly affected by this dialectic. Worldwide, 2/3 of our energy is consumed in cities. In the 21st century, cities are not just the main contributors to climate change, they are also struck by it in a particular manner which implies specific and new answers. Although indoor and outdoor climates are obviously linked to each other, their examination has proceeded along different paths and there has been remarkably little crossover conceptually so far. Today, however, architecture's one-sided obsession with controlling the indoor climate of individual buildings has to be questioned and the thermal dialectics between inside and outside of cities to be examined and taught instead. The practice of climate control has to be conceived as part of larger energy landscapes and thus as the result of the dynamics between the urban fabric and the anthropogenic climate. The historian Deborah Cohn speaks of governance on other scales. The city as indoor environment. Already during the 20th century, modern architects experimented with an indoor that exceeds the scale of the individual building. In 1931, New York architect Raymond Hood, for example, speaks of the idea of, quote, a city under a single roof. Buckminster Fuller's tension integrity structures and Frei Otto's air structures are examples of such extended interior spaces that are no longer buildings in a conventional sense of the word. The idea of the house has been gradually being replaced by these experimenting architects with the idea of large-scale environments that are committed to overcoming the internal-external opposition. Buckminster Fuller's concepts, developed since the 1940s, culminating in the today famous dome over Manhattan, have deliberately promoted the expansion of the span length and the dissolution of the conventional building. Lisa Heschong, one of the contributors of our new anthology, commented in 1979 on the dome as follows, emphasizing the idea of an indistinguishability of inside and outside areas. Quote, this climatic envelope would enable the entire city to be air-conditioned, indoors and outdoors. Indeed, outdoors would be a thing of the past. End of quote. Concepts of large-scale indoor spaces, such as the dome over Manhattan, illustrate modernity's great dream of countering the polluted and overheated city with the purified and cooled interior for the privileged ones. These spaces are, to paraphrase a title of the magazine Architectural Design from 1972, designed for survival. Highlighted also in Juan Navarro Baldewic's vision of generic ecosystems equipped with a climate control system. The pneumatic bubbles floating in New York's harbor are only one of various projects promoting artificial urban microclimates. First steps towards the implementation of a city under a single roof have undertaken by the Biosphere program in the 1980s. The so-called biosphere has been designed as an autonomous residential zone equipped with a self-sufficient thermal energetic concept. However, a sense for the mutual reactions between inside and outside was not promoted by these projects. In this respect, concepts such as the dome are to be interpreted as mere allegories of a new form of conditioning entire cities. The idea of the large-scale envelope emerged in disregard of those thermodynamics of modern cities as being described since the beginning of the 20th century by urban climatology. It was systematic meteorological comparison between city and countryside that showed for the first time the stunning autonomy of the city climate. So this is probably the first scientific illustration illustrating the so-called urban heat island effect, showing a section through Vienna, and then you see the increasing temperature rates in the middle, in the city center. The modern basics of this research were developed in Germany between the world wars. In 1927, Rudolf Geiger published The Climate Near the Ground, das Klima der bodennahen Luftschicht. This was followed 10 years later by Albert Kratzer's seminal The Climate of Cities, das Stadtklima. As Kratzer's book demonstrates, there had been extensive research on German and Austrian urban climates in the early part of the century. Meteorological studies were conducted, for instance, in Vienna, Linz, Stuttgart, and in Karlsruhe. These studies were evolving in parallel with the widely unregulated industrial landscapes and the development of the new architectural principles of the modern movement. Think of the settlements Weißenhof in Stuttgart, Dammerstock in Karlsruhe, or the new typology of urban terrace buildings in Vienna to recognize the historical intersections of scientific and architectural approaches to urban climates. The climate of a city is marked by three fundamental influencing factors. Firstly, the hermetic ceiling and the sheer presence of the buildings. Secondly, the artificial input of heat. And thirdly, the pollution of the air. In the words of climatologist Rudolf Geiger, quote, "The basic reason for the differences found in the city climate is the alteration of the heat and water budgets. This is caused by natural ground becoming largely replaced by stone, from which precipitate water is quickly lost, and because the roughness of the surface has been increased by the presence of buildings. In addition, heat is supplied by domestic and industrial fires, and finally, city air is rich in dust stirred up by traffic and in exhaust fumes from vehicles, from fires, and from industrial works." End of quote. From the perspective of urban climatology, the city as indoor environment results from the mutual reactions between the various microclimates inside and outside of buildings. In this respect, the statement by the British climatologist Charles Ernest Brooks from 1951, quote, that not only the existing climate is to be considered, but what it will be after building is completed, end of quote, expresses the central epistemological prerequisite behind the notion of city climate. Urban climates are not given, but rather man-made artifacts. The scientific ideological rationale that held the two groups of scientists and architects together was the discourse on hygiene. Industrialization, urbanization, and eruptive modernization have had an enormous impact on the evolving European cityscapes since the early 19th century, not just in terms of the urban structures, but also concerning their urban climates. Carl Friedrich Schinkel's journal documenting his visits of London and Manchester in 1826 reveals how deeply he was impressed and puzzled by the new industrial landscapes of England. According to an entry, the factory chimneys are, quote, smoking obelisks, connecting the new man-made atmospheres to the picturesque taste of his time. The lack of understanding for these new industrial environments promoted the use of a metaphorical vocabulary. Modern research on urban climates were strongly motivated and influenced by the air-polluting effects of factories and the poorly ventilated residential districts of the working class. The fundamental problem of urban hygiene, as particularly manifested in the overpopulated urban districts and addressed most prominently in Friedrich Engels' The Housing Question of 1872, continued to concern European societies during the 20th century. The new city, coined by the rapid and random growth of urban settlements, is, as Ludwig Hilbesheimer writes in 1944, characterized by three deficiencies. Quote, in the first place, no effort was made to locate industry in proper relation to residences. No thought was given to prevailing winds. Therefore, the smoke, soot, and fumes of our industrial cities constitute an evil with grave consequences to the health of the people who live there. In the second place, houses in the residential districts were built without the slightest thought to the need for sunlight on the part of the people who would live in those houses. The population density is highest in the worst and unhealthiest parts of the city. Recreational areas in those sections are direly needed. In the third place, the disorder within the city area, the indiscriminate conglomeration of industrial, commercial, and residential districts gives rise to almost unsolvable traffic problems. End of quote. By conceiving cities as product of empirical growth rather than of planning principle, Hildesheimer connects to the insights of urban climatology. The city of his time is insufficiently organized, leading to severe environmental problems, and the artificial urban climate has an uneven impact on the population. The most densely populated residential areas are the unhealthiest ones, insufficiently ventilated and often without any access to direct sunlight or central heating. With reference to studies by urban sociologist Louis Wirth, Hildesheimer emphasizes the correlation between the urban climatic and the urban social structure. Such a correlation is registered in many cities throughout the 20th century and until today. It was a strong motivator for the new large-scale modern urban developments in Germany and elsewhere since 1925. In general, the block layout gradually evolved from the original hollow square with 4 street frontages to a final organization according to which all buildings facade faced in one direction, arranged without direct street frontage. Toward a theory of practice. From the outset, the practical implications of urban climatology for architecture and urban design have been recognized and emphasized. Quote, the density of built-up areas, the height of the houses, the distance from one another, the width of the streets and squares, their orientation and their plant life, all of these have their effect on the temperature picture of a city, was how climatologist Albert Kratzer formulated his research hypothesis in 1937. In a nutshell, these aspects contributed to a future theory of practice which is in the center of gravity of the scientific and architectural discourses on urban climate. I call such a theory an urbanized theory of passive climate control. The evolving modern districts in Europe, the new towns in the Soviet Union and in the European colonies, as well as cities under extreme climates, have been the testing grounds where urban climatic conditions have been considered and the new climatic knowledge applied. Historically, 4 main concerns have been in the center of applied climatology and the new modern city. Firstly, the sun and other environmental factors as form-defining forces, known in the literature as heliomorphic design. Secondly, the reasonable siting of urban districts and buildings related to the foundation of new towns. Thirdly, the ratio between buildings and green spaces and greeneries in the public spaces and along the facades. And fourthly, the regulation of solar access and thus the thermal interplay of buildings. Over the course of the 20th century, the urban climate was an important driver for reconsidering the structure of cities, since the urban climatic conditions were closely associated with questions of hygiene and health, and later, in the second half of the century, with questions of energy and comfort. While applied climatologies of the 1920s and 30s was still separate from energy issues, focusing on urban microclimates, energy conservation gained increasingly importance in the second half of the century, considering the urban environment as energy landscapes. Climatologist Gordon Manley identified 3 fundamental areas of architectural intervention which can be conceived of as the central means to mitigate or to control the climate of a city in a passive way: the buildings, the plant cover, and the topography. A theory of practice draws its architectural vocabulary from all these three fields of inquiry: buildings, green spaces, and topography, conceived, of course, in close relation to the climatic factors. The sun was in many cases the starting point of the architect's investigations and the main reference of new solar geometries. So-called heliomorphic design has been an important model for investigations on how to make environmental factors fruitful. Since the beginning of the 20th century, there has been systematic research in controlling solar heat gains in cities by considering also the impact of neighboring buildings. An urban shadow science led to an understanding of how the sun's energy can be utilized. It formed the basis for a city plan laid out on scientific sunlight principles. The hospital and the street canyon became an exemplary and especially interesting point of intersection between climatology and design. Hospitals appear as symbols of the modern debate on hygiene, and the street canyons as symbols of the evolving modern cityscapes at the turn of the 19th century. The form of the volumes, the width to height ratio, the surface materials oriented at a particular angle, the sky view whose geometry determines sun access by day and loss of energy by night are some of the factors being discussed. In William Atkinson's 1912 study, the orientation of buildings, for instance, hospitals and street canyons, are highlighted prominently. The sunlight and the shadow, as they appear in hospitals and in the street, are the main concern of the author. In the case of hospitals, new typologies, such as the terrace house and the reasonable siting inside or outside of cities, have been discussed in close relation to urban climate considerations. Due to the severe microclimatic conditions, the move of hospitals out of cities to more rural sites was a universal tendency, as Nicholas Pevsner emphasized. In this respect, the modern debate on hospitals have been exemplary how urban climates were affecting the design process on different scales, from X-large to small, from urban planning to constructional detailing, transforming the structure of the cities. In a patent submitted by Peter Behrens in 1933, the scales of the building and of the city are brought together in a meaningful manner. The idea of the urban terrace house has been developed further to a city with shifted pyramidal structures, considering the mutual influences of the buildings on insolation. Due to heliomorphic analysis on an urban scale, the rectangular arrangement of the terrace houses has been abandoned in favor of a setting of displaced pyramids. Heliomorphic design, as elaborated by Atkinson, Behrens, and others, have been developed further by using new techniques of simulation in the laboratory. Henry Wright's research yielded a remarkable new form of empirical analysis of sites in the laboratory, anticipating those methods used by the Olgai brothers 2 decades later. The architectural study of urban climates promoted a new modern sensitivity for the interdependence of the building and the city scale. Housing and urban development, as architect August Schmaus formulated in his 1914 article, Climatological Principles in Architecture and Urban Planning, form a unit. While conventional bioclimatic architecture isn't concerned with the neighboring built environment, in the case of cities, the built context requires a profound analysis in terms of climatic implications of the geometries. Urban architecture, referring to climatic factors such as the sun or the winds, entails the examination of the buildings, the green spaces, and the topography. This promoted an architectural understanding which is generated by co-production and synergy of building groups and the built environment as a whole. By examining buildings not as individuals, but rather as part of wider urban settings, building envelopes acquire a meaning that transcends the conventional notion of a common appearance of the street as envisioned by Abbé Logier in the mid-18th century. According to Logier, the facades of the houses cannot be left to the interests of private individuals. Accordingly, local governments not only have to determine where to build, but also how to build. Over the course of the 20th century, however, building envelopes transcended these visible public dimensions, linking the envelopes to the city climate too. Such an understanding of urban energy consumption was theorized since the late 1960s. Landscape architect Michael Hough coined the term energy landscape, referring to an ecological view that encompasses the total urban landscape. According to Hough, the urban fabric and the urban climate have to be conceived as energy commons. In the 20th century, the availability of cheap energy has been the overriding determinant of urban form. Historically, however, groupings of houses around greens and courtyards were arranged on the basis of functional necessity to conserve heat, minimize winds, and provide access to sunlight and space. In the words of Michael Hough, quote, "As pressures for energy conservation become more urgent, we must look for environmentally sounder ways of manipulating the climate of cities than the present total reliance on technological systems." End of quote. The central question is then how the exterior environment can usefully conserve the city's energy. In this sense, energy-conscious planning and building in cities does not only mean to promote the usage of renewable energy sources, such as wind, but also, and in particular, to analyze the characteristic ability of the wind to significantly influence the heating requirements of interior spaces through the transfer of heat. This mutual reaction between exterior and interior zones forms, in essence, the intellectual program of an urban theory of passive climate control, integrating urbanism and ecology, and above all, inside and outside. Architect Ralph Knowles systematically examined the geometry of the city regarding its potentials for solar heat production and for an improved energy performance, considering widely also the political aspects of passive climate control in the city. Knowles linked heliomorphic design to the question of solar access and, accordingly, to thermal governance. Quote, "To use the sun, you must have access to it. To have access, there must be a public recognition of the right of access, a solar policy." End of quote. Ralph Knowles' request to govern solar allocation is an expression of society's need for coordination in order to generate the highest performance of buildings and the highest comfort of outdoor spaces in cities. Today, we have to critically reassess these historical approaches of heliomorphic design strategies in the light of changing climatic conditions in cities and recombine them to a contemporary theory of practice. In our archaeology of city climate, the appropriation of the insights of urban climatology by modern architecture is scrutinized in general over the course of the 20th century, but also by looking at specific historical contexts, namely German ones of the 1920s and 30s and North American ones of the 1960s and 70s. The archaeology examines the transformation of the scientific object, the urban climate, into a design artifact, and thus the applicability of urban climatology's insights in the field of architecture. The archaeology identifies major design approaches for reducing environmental and thermal loads in cities, mitigation and adaptation strategies on the one hand, and energy conservation and passive climate control on the other. However, the archaeology of knowledge explores both the adaptation of the concept of city climate by architects and the manifold failures to apply the insights of urban climatology in the built environment. Think of contemporary cities all over the globe. In 2013, Michael Hebert and Fionn McKillop characterized urban climatology applied to urban planning and architecture as a post-war knowledge circulation failure. Quote, "The application of climatic design principles remained localized and little known until the rise of concern over global climate change prompted fresh interest in the present century." End of quote. In the mid-20th century, the exchange between urban climatology and architecture still seemed to be a promising undertaking. By setting up a mutual relationship between climate and architecture, urban climatology both undermined and transformed the monocausal and one-way approach of bioclimatic architecture. Not only climate shapes architecture, architecture shapes also climate. Today, we have to recalibrate our architectural attitude towards climate in research, teaching, and, of course, in practice. Come to the last part of my presentation, new topological operations in architecture. How to live in the increasingly overheated and polluted cities of the 21st century. How to cultivate certain microclimates and transform others by architectural means. In the center of a contemporary architectural understanding of climate and climate control are, as we see it, urban microclimates conceived as artifacts. By conceiving microclimates as important elements of the material culture of urbanized societies, the quantitative approaches of urban climatology and building science are extended towards a design perspective. Epistemologically, microclimates are nature-culture hybrids. If we follow Bruno Latour's concept of the agency, the primary task consists of revealing the stages of mediation between humans and non-humans so as to reach an adequate understanding of the materiality and the making of microclimates. As natural or technical phenomena, microclimates are thermal zones with site-specific physical characteristics. They are affected by temperature, moisture, rain, wind, fog, snow, insolation, cloudiness, air quality, and more. As man-made artifacts, however, microclimates are, in the sense of Lisa Heschong, fabricated thermal places with various ecological, social, and political meanings. Since microclimates have both tangible and intangible aspects, they must be examined on many different levels. They are tangible as physical objects where the buildings, parks, heating systems, or thermal infrastructures are involved in generating them. And they are intangible in as much as people and groups, the way they behave, their institutions, and their political directives are involved. Microclimates are manifest in a constant interplay between visible and invisible materialities. In the light of a theory of practice as outlined above, urban microclimates are man-made artifacts, not only empirically, but in particular as the result of deliberately designed forms of architecture. As architect, to design and construct microclimates requires a sense for the cultural complexity and the temporal dynamics of thermal places. In our new anthology, the highlighted architects show various approaches towards the design and construction of urban microclimates. They are created through passive and active forms of climate control and related to mutual relations between indoor and outdoor spaces. In all the chapters, microclimates are embedded in a scalar dynamic that transforms our understanding of physical context and transcends the conventional divide into inside and outside areas. The contributions of the anthology remind us of basic architectural strategies of negotiating and designing linkages between indoor and outdoor areas. Let me highlight 4 examples considering these linkages by architectural means. First example, Philipp Rahm interprets microclimates as physical and chemical entities always in close relation to the body's physiology. On different paths throughout the Jade Eco Park in Taichung, Taiwan, the visitors will encounter various thermal sensations. The experience of being indoors is in this case also provided in the so-called outdoor space and vice versa. In addition to the cooling and purifying effect of the park greening, geothermal energy is used for the dehumidifying and depolluting devices. Rahm's thermal approach, beyond conventional ideas of comfort, is a model for how the microclimates of today's cities must be consciously designed. Second example, in the case of the House of Brazil in Paris, initially designed by Lúcio Costa and built by the Atelier Le Corbusier, the thermoregulating ideas of the French engineer André Missenard has been applied, who suggested that the difference between outside and inside should not exceed 7 to 8 degrees Celsius. Instead of decoupling indoor spaces from the climatic conditions outside, the mutual dependency might enable a stimulating thermal environment for the human body. While the underfloor heating system heats depending on the zone of usage, a passive ventilation system prevents overheating during summer. Being a hostel for Brazilian students in Paris, the deliberate construction of different microclimates inside makes the Maison du Brésil a metaphorical machine reminiscent of the students' origins. Third example. For Richard Neutra, the connection between indoors and outdoors was the most important aspect guiding his architectural designs. Neutra considered the outdoor air healthy and the indoor air harmful. In his Kaufmann Desert House in Palm Springs, the residents could comfortably breathe the fresh air outside, the outside air, while at the same time being mechanically warmed from below. Through underfloor heating inside and outside of the house, this villa had no clear physical boundary. Although energy costs and environmental concerns were of no significance, the Kaufmann Desert House may serve as an inspiring starting point for reconsidering the thermal interplay between indoor and outdoor spaces. Fourth example, in sharp contrast to this technology-driven solution, Francis Quéré promotes buffer zones between the outside and the inside to mitigate the heat, but also to create shaded spaces where school children could play or eat. Such buffer zones promote social interaction and are insulating the buildings. Through his work, Quéré underscores a democratic access to microclimate production, even though social class and status still too often decide about the selection of climate control strategies. For Quéré, passive means of climate control are the true luxury, not mechanical air conditioning systems that make one dependent on electricity. By focusing on the stabilization of thermal conditions inside of buildings, climatic concepts of the 20th century tend to overlook the growing epistemic interdependency of outside and inside areas. Insulation of walls and sealing of indoor spaces for more effective climate control became a standard with hegemonic significance, leading to the idea that people live in encapsulated and isolated worlds. However, today design strategies must reassert the links between the indoor and outdoor as part of a broader engagement with the urban climate, as geographer Gerald Mills pointed out in 2011. The distinction between two clearly separated Spatial areas, indoors and outdoors, is an invention of modernity that we can't take for granted any longer in the 21st century. What's on the horizon is, as our research shows, the city as the new indoor environment of societies, or more precisely, the diversity of mutually interacting urban microclimates, which does not follow the blueprint of a binary code. Instead of homogeneously controlled buildings, an extended field of comfort based on the deliberate structuring of the city's microclimates should emerge. Future architects will focus on creating a thermal environment in and around the building rather than simply provide a thermal infrastructure within. Climate change and city climate phenomena undermine modernity's ontological self-positioning in the world. They call for a new topological thinking in architecture, exploring operations of interconnecting, linking, interweaving, distorting, folding, or averting, and promoting a new thinking in singularities, relations, and transformations. In this respect, the Möbius stripe is a critical thought figure of our epoch, displaying indoors and outdoors as one continuous energy landscape. The old modernist essentialism of a world with basically two separate areas, the interior and the exterior, has to be radically questioned today. Instead, the principle of permeability examines the topological interlocking of different perspectives confronted with manifold ambiguities and all sorts of distortions and complications, entanglements, and developments that lead from one form to another, countering the idea of essence. In the words of the Brazilian artist Lydia Clark, the inside is the outside. The imperative of integrating indoors and outdoors in order to reduce environmental and thermal loads in cities is the primary challenge identified by our archaeology of city climate. It emphasizes the critical agency of the architect for this integration. Thank you.
Thank you, Sascha, for the great presentation. And let me now introduce also our respondent, Alice Hertzog, whom I know very well, but I will still read very precisely your bio. Alice is an urban anthropologist who joined the Transdisciplinarity Lab at ETH Environmental Systems Department in 2014, and her current doctoral thesis investigates patterns of migration and urban development along the Lagos-Abidjan corridor. Some of that migration is caused by climate change, and thereby also a direct link to Sascha's work. Alice studies how this migration shapes the cities where people move and the places where they come from, thus the link between the city and the countryside, and the focus on housing strategies and translocal urban development. Her work is part of an ongoing collaboration with the Global Program on Migration and Development at the Swiss Development Cooperation, and it is supervised jointly by Professors Christian Schmid in this department and Dr. Pius Krutli. Thank you, Alice, for joining. So, fascinating ending of Sascha's lecture. Those wonderful images of maybe a strip, Lydia Clark, and consideration, philosophical, of the notions of inside and outside. And what, let's say, very strongly resonated for me in those images is also the notion of the inside and the outside, let's say, at a planetary scale, to say so, or within the processes of urbanization. So the notions of inside and outside are also used in urban theory to signify the position inside the urban transformation, and outside being the nature as a locus which is outside the urban, or the rural as being something that is opposite the urban. And of course, Anthropocene is precisely the statement in which we recognize that we cannot anymore escape, or that outside does not in fact exist, that the outside is profoundly absorbed, let's say, within urbanization processes, and that this also changes our position as agency within those processes. So I was very intrigued by your presentation, which kind of systematically asks us to think across various scales, and you reminded us that let's say there is a kind of a profound history of climate as a strategy of urban or territorial design, let's say, design at very large scales, which I greatly enjoyed. So I have many questions, and perhaps I would ask you, tell us a little bit more, how do you see the priorities in education? I mean, you outlined it quite clearly in the end. How to integrate those questions once again in the, let's say, work of architectural urban design studios. How to shape those priorities once again?
Yeah, it's a big question. I think in essence, it's really about, I would say, overcoming our today's focus on individual buildings when it comes to question of energy, climate control, and so on. And also our concepts of sustainability are very much related also historically to individual buildings. If we look at the magazines of the ecology movement of the 60s and 70s, you see beautiful landscape with an abandoned house in the middle, and then it's kind of the idea of a self-sufficient, autonomous, production of energy, and there's no urban surrounding in these cases. And I think we kind of transferred these concepts developed by the ecology movement to our contemporary cities. We use them also as a prerequisite, and I think today we really have to overcome these kind of strategies. Well, overcome. We have to transcend them, let's say, not overcome, transcend these approaches of the 1960s and 70s, mainly by including, first of all, the urban, which means looking at groups of buildings, or also at the district scale. So buildings are never alone in a city. So what are the possibilities to kind of integrate several buildings together in terms of energy production, transmission, but also consumption, and then maybe even in terms of a passive strategy. So what's the thermal interaction between buildings? I showed these images of of insulation, but also of blocking the sun. So these are like first steps of an analysis, I think. And frankly said, we must also consider we are at a very primitive stage, in the understanding and descriptions of these kind of phenomena. I talk a lot also to Arno Schlüter here at ETH, and they of course try to simulate, but they fail also in terms of resolution. I mean, these are really big data problems, so to simulate the climatic conditions of a district or even of several buildings taken together.
I'm very excited because it addresses directly my field of territorial design and planning, so I'd love to discuss more. But first, Alice, would you like to respond?
Yes, I mean, thank you for the talk. It really got me thinking about this inside-outside. You know, where are the boundaries that we put, between those different spaces? And we've been working quite intensely over the last few weeks on a book project about extended urbanization. And if we were to think about it through the lens of that, then the challenge would exactly be, well, maybe there is no outside anymore. Where would we draw that boundary? Is that the periphery, or is that the operational landscapes outside the city? Is that the hinterland? Or are, in fact, all of these territories parts of processes of urbanization? So on the one hand, I had that in mind. On the other hand, I had my kind of hat as an anthropologist on as well, listening to this inside-outside. I was thinking, well, this dichotomy, which is incredibly strong in the way that we live our lives, does change a lot of our practices. You know, I definitely don't wear the same clothes inside as I do outside, or have the same kinds of relationships, or eat the same kind of food. A lot of my everyday practices, as I go around my everyday life, are dictated by whether I'm at home, inside, or outside. And so I was thinking maybe we kind of need a closer reading of that as well, because all of those practices are also linked with how I react, or how one reacts to one's thermal environment. I was wondering whether, okay, there's the dichotomy, but there's of course a spectrum within that inside-outside as well. There are multiple shades of insideness that go to, the patio, the terrace, and finish with a very, very outsideness. But maybe there are some inside-outside places as well that we can be thinking about. So not necessarily to kind of throw the baby out with the bathwater, and still recognize the importance that distinction has in how we live our lives and how we experience our cities as well.
Yeah, that sounds very reasonable. I think we probably continue to use these terms also in the future. But I think of course, it also relates to a particular surrounding here in Switzerland. We are really used to, as architects, to refer to this dichotomy or to this divide of inside and outside, and it raises a lot of crucial problems also. And so in this sense, I think, of course, we have to do both, question the divide, looking for more differentiated microclimatic conditions, while still, of course, looking for privacy, etc. So we won't overcome the need to have a private space,
Perhaps
of course.
you could give some illustrations from your own work, because Sascha's work, I would actually describe it as really deeply ethnographic and anthropological in the way that you handle your cases. For instance, the climate control in the HDB apartments in Singapore, or tobacco barns in Sumatra. So these are kind of, let's say, socio-cultural climate practices which you described and analyzed at a very, I would say, one-to-one scale almost. Yeah. So there is a kind of a very profound understanding of, let's say, culture of urban dwelling as something which ultimately shapes the urban climate. Mm-hmm. Perhaps you want to just tell also for the audience about some of those investigations.
Yeah, well, one part of our research, we are a small team of 2 doctoral students, 2 postdocs, and they all do field work also in different cities in the world, in Santiago de Chile, in Cairo, in Chongqing in China, and most recently also we focus on Geneva. And of course, this fundamental divide, which also coined our idea of energy efficiency, is only valid, let's say, in 1/3 of the global building production. The vast majority of people they don't live with this kind of divides, right? So they have a very fluent microclimatic environment. For instance, in China, Chongqing, which is in the so-called non-heating zone in China, so the houses don't provide thermal infrastructures. So people really have to find a way to cope with the climatic conditions. Many times the outside is warmer than inside. So what is outside then, or inside? So kind of coming home means to take the jacket and wear it inside, right? Not take it off, as in our case in Switzerland. So I think it's a very differentiated environment and not really in the same way coined. Nevertheless, I think also China is importing our concepts of a strict divide, you know, this 20th century idea of having a clear, thermally clearly defined interior and then the unconditioned outside or exterior. So in this sense, it's a globalizing phenomena with many different layers. But I think it's very interesting also to look on an ethnographic, let's say with an ethnographic approach, what people really do at their home, and we will encounter, I call it inversions, where the inside is really the outside, and vice versa.
I mean, I think that with this question of thermal diversity, you're also looking at huge diversity within cultural contexts as well. I mean, from a chilly house in the UK to, you know, a home in the Amazon, those are all going to be very, very different strategies. And I mean, in your work, you showed how architects have developed design solutions or architectural solutions to respond to that. What are some of the solutions that your ethnographic fieldwork is coming up with, or some of the insights that you're gaining from those case studies?
And if it relates to particular...
In terms of design solutions that people are using on a day-to-day basis.
Maybe kind of vernacular solutions or the new vernacular.
Yeah. For example, in Cairo, how are people responding to the challenges of thermal diversity at the moment?
In Cairo, people, I mean, mainly women, frankly, so because they have to stay, they live inside mainly, right? So the men are kind of allowed to explore the entire city. And yeah, Dalila Godban, one of our doctoral students, she really explored one of these apartments, how it has been changed over the course of a year. So like these women adapt constantly, like the objects and also even the walls of their environments, of their apartments, according to changing seasonal conditions. So it's kind of an ongoing project which interlinks the thermal aspects with everyday aspects. So it can't be separated in a strict sense of the word. So there's not the thermal thing and then like other concerns. Everything is kind of entangled in a certain way. So I think this is a very exemplary way how people cope with the climatic conditions. And one question is how we recognize these kind of practices, because the examples explored by Dalila, they are taking place in the old town and they're kind of protected, you know, it's kind of heritage, cultural heritage of Cairo, but the people, they have completely different approaches, right? They want to change their environment. And the question is, how can architects take these approaches and integrate them also in their own concepts?
Or maybe just leave space for them to be produced as well, or leave the available flexibility within the building for those, I don't know, those curtains or shutters or things to be added on as the climate changes. I mean, one of the things I thought also listening to you was how deeply embedded this thermal question is with energy prices and what is feasible and what is not in different moments. And I know that where I come from in the UK, there's a real rise in energy precarity, and that's closely linked to how homes are being turned into smart homes. Mm-hmm. And quite often what that means is that when the energy company renders your home smart, they'll introduce a meter where you have to put the money in. So before you would pay a monthly bill, and you were protected. So if you didn't pay that bill, you'd be given, you know, an extra month, an extra few months, and they wouldn't cut your energy off during the winter. But with the rise of smart homes, we're seeing that because people are having to top these meters up with their phones inside the house, that the meters are turned off as soon as there's no more money in there. And so we have families, you know, in London, in Manchester, really quite parallel to the housing questions and to some of the things that Engels was looking at there, that are living in, you know, very cold houses with no energy. And that seems to somehow go hand in hand with a kind of new, smart, sustainable discourse analysis that actually is being used to create pockets of thermal precarity within the urban environment, and that's kind of one of the disturbing kind of consequences of this as well.
Yeah, absolutely. I also, I mean, you can look at it in terms of energy, but also in terms of climatic or thermal loads in a particular area. So, as I also said, referring to Ludwig Hilbesheim, it's an issue over the course of the entire 20th century. So who is really profiting from certain urban, let's say, measures and who not? So I think vast parts of people have to really cope in everyday life with quite severe climatic conditions.
And I guess another thing about that inside-outside dichotomy is that we protect people on the inside. You know, we render their lives comfortable, people who are inside our house or inside our community, and people who are outside have to gain access to that or have to struggle to access that. So I was also thinking about if the city then becomes the inside of, you know, a certain control of thermal comfort, then what happens to the people on the outside as well? And I think this is increasingly the case I see it in my work in West Africa, where people very far out on the hinterland, very much suffering from the consequences of climate change. And a way to protect oneself from those rising temperatures, from those flooding, is to get into the city as well as a livelihood strategy, to get into the inside where markets are still available. Yeah.
A couple of questions are really, let's say, burning in my mind, and one of them has to do with the notion that you mentioned, that the climate field is increasingly, let's say, the meeting place between scientific investigations and design investigations, and therefore the kind of meeting between the quantitative and the qualitative in terms of values, to say so. And I am curious. You're a researcher who really keeps an eye on both sides of that equation, and as a designer, I think that this possible meeting of the different cultures is something that that of course we aspire to. That would be terrific. But I'm wondering from your research, I mean, do we have aligned our agendas? Do we actually, can we translate the kind of quantitative priorities of, let's say, you know, whether it's energy consumption, you know, 2,000 watts per person, or a certain CO2 margin? Can we translate that into social structures, urban spaces, certain kind of ideas of social equity and so forth?
Yeah, that's a really important question. So how to kind of translate the knowledge of urban climatology into the field. And I see there is an enormous amount of studies, you know, quantitative studies, also studies trying to develop new methods being relevant for urban planning and architecture, but nobody's reading it. So there's like a community on its own dealing with these kind of questions. On the other hand, there are the architects. So how how to set up like a communication is like a task on its own. And I think there are few examples of really smart architects, landscape architects, being able to kind of read and understand these recommendations and then trying to develop an own agenda for architecture and urban design. But looking at these publications, I must say it's quite interesting. Then you would find mainly new methods, no case studies, no designed work. So what is like the architect working in an office doing with these kind of informations? So there's really like a tension, a fundamental tension between methods on the one hand and case studies or aesthetics on the other. So, and I don't know how to kind of solve or overcome these kind of tension. And then the other thing is, okay, there's urban climatology, the science conducted by scientists, meteorologists, and then there's this notion of applied climatologies. And so what is applied climatology? Applied climatology is, for instance, heliomorphic design, as I described it, so really systematically explored the geometry of, let's say, an urban constellation of various buildings and how the buildings affect each other. But I think there must be like another level of interest, and this is kind of the interpretation of the existing cities in terms of climatic potential, and that's the work of architects, I think, also. It's the vast majority of all buildings, looking at them and what are their implications for the urban climate. I think that would be like a task, again, on its own, and I always like to also show examples which I believe they are really super interesting also in terms of responding to the urban climate, but they haven't been meant as kind of an explicit, you know, climatic answer. For example, this example of Asnago Bender, which I showed from Milan, right? So these were not climate architects at all. But nevertheless, I think the way they kind of differentiate different directions of the facade, different materials, openings, it's really a play with the microclimatic conditions. So that would be like another, let's say, level or approach. So looking at the existing city and try and start to reinterpret it in terms of climate conditions.
So from our discussion, it appears, of course, that we could use the notion of specificity as the notion which kind of qualifies urban climates or the nature of research. We could say that due to both, let's say, cultural and geographic reasons, cities are specific climate constructs, to say so. There are cultural elements, as you described, ethnic, even this climate is even gendered, as you pointed out. So, let's say, designing climate is a kind of profoundly specific undertaking, you know, depending on the context where we are, right? And I wonder how in such specific situations, let's say, what is the difference from your research in, let's say, Geneva and Singapore or Sumatra? I mean, how do you construct, let's say, if you approach those as design questions, how do you construct priorities? Do you guide yourself with specific quantitative parameters, or do you have another range of priorities in mind?
Yeah, well, we have not like an overall, you know, frame for all the cities. It's very specific. So what we are kind of investigating. So but nevertheless, I think, of course, each city is different. But then, of course, you can compare for instance, the significance of thermal standards, which is high both in Singapore and in Geneva, but not in Cairo. So, so they have not like a bigger role, let's say. So I think in general, I can say our approach, we always involve three fundamental, let's say, topics. We call them thermal regimes, thermal practices, and thermal structures. So we look at structures, built structures, infrastructures, but also at the practices. And in the case of Cairo, the practices are key, are very central. You know, there are no infrastructures, and the architecture is not relevant. It's just one layer of brick. That's it. So there is no insulation, and there is also this layer of thermal regimes, of course. So that means the norms, the thermal standards, etc. And I think it's always an interplay, of course. Even in the cases of an absence of explicit, let's say, norms. There is a norm, you know, like an everyday practice, let's say. So I don't know, maybe I lost a bit, but I think...
It's a good answer. I think it's a great answer. Thank you. It's very helpful. Do you...
Yeah, I mean, just one. Sure. Also, I mean, we can really hear the Foucault coming through in your work, in this idea of thermal regimes. With the, I think during your lecture you also managed thermal governance. Could you say a bit more about that, about how thermal agency is co-produced, and in your work, who you see producing that agency? So there are architects, but you also kind of allude to many other people shaping that agency as well.
Yeah, it's kind of a new term also for us, this term of thermal governance, and we use it to describe the need to address new scales of regulation when it comes to climate control. So that's this very idea of a new thermal indoor of societies. So I think we can't only focus in the future on individual buildings. So we have to find a way to regulate larger, let's say, entities. Maybe not the city as a whole in the first step, but let's say one particular area or a district. So how to organize it also, and in terms of insulation, for instance, or solar access, as addressed by Ralph Knowles. So I think these are like first questions or aspects related to a new form of thermal governance on a city scale. And of course, I think the architects play quite an important role also for the development of such a new understanding of governance or thermal governance. But we are, I think, really at the very beginning, at a very primitive stage, wherever we would look at.
So mentioning the word primitive, I'm curious about the kind of relationship between the primitive and something which is, to say, so smart or intelligent or non-primitive, so the relationship between the low-tech and the high-tech approaches. Perhaps I will be speculating if I say that such simple things like planting trees have always been very helpful in terms of climate creation. And I wonder to what extent or in what cases do you think we, or in what way, you know, are those various technologies from low tech to high tech important or valuable, or how do you see their relationship?
That was a great quote from Kere saying, you know, the passive is the real luxury in the end, to have something that doesn't depend on being able to put the pennies in the meter.
Well, given the fact that we have to decrease our energy usage in general, so I think passive strategies, they have certainly a certain relevance and also future, I think, also in our areas. Nevertheless, I think we live in a highly developed environment, and I would not exclude, let's say, the possibilities of current technologies. So big data is, of course, also of great significance in order to describe the energy usage of entire districts and then the management of energy. So I think I certainly see the use of these kind of technologies. Nevertheless, I think, yeah, I really think we are the very primitive or limited understanding, although because we have a society based on privacy, right, on private ownership, and it's also a question how to overcome, at least in certain parts of society, this privatized approach to buildings, for instance. So how to develop a larger view of a district, and then how to manage the energy sources consumed in such a district. So these are quite, I think, interesting questions, and they can be developed further. And yeah, planting a tree is a nice thing, and I think it also relates to the education of architects today. So my impression is we really have, as teachers, to train a new generation in order to have better results than we maybe provided, or our generation has provided. So, yeah, I think technology, education, and low-tech architectural strategies have to kind of complement each other. I don't see another.
Mm-hmm. Wonderful. It's a great answer, very inspiring, and now to the new generation, which you mentioned, our audience, our students. Would you like to speak, to ask questions, to debate with Sascha and with Alice?
I have a question just whilst you guys get rolling. I mean, you've showed a lot of good practices here, a lot of things that students could take on as kind of do's. Are there any big don'ts that come to mind? Bad practices that you've encountered systematically and that are coming back again and again, and that you think are kind of impeaching a future architecture that takes into account thermal regulation?
Bad practices.
Don'ts.
I don't know. I mean, our cities are full of bad, I don't know, examples, right? So look at Arabic cities. I mean, modern Arabic cities. I mean, it's simply amazing, right? So how they are constructed, the scales, and also the speed of transformation, and ignoring all kinds of climatic or let's say very basic climatic considerations. So I don't know, I don't have now the really bad examples for you, but I think we really have to kind of transform our understanding of and our approaches to climatic questions all over the globe. And yeah, look at Dubai. So there are not many trees maybe influencing the local microclimates.
Yeah, I had a question on, or at least I was quite interested by what you were mentioning of the fact that we have the building, and that we always talked about the building itself, and all the example that you were showing also when you were saying the inside and the outside, you had still kind of two layers of saying you have the buildings in the comfort, and then you have the urban. And and you were mentioning this exactly this desert city, not the bad example, but the good one of where you have let's say an oasis, you have the deserts, you have probably 60 degrees outside in the deserts, then you start to arrive in the city. You have the large streets where maybe you reach the 50 degrees, and then you have smaller streets where you arrive at 34, 40 degrees. Then you arrive to the courtyard, and then you arrive to the building inside, and in the building inside is 24 degrees. And so with this, suddenly you don't have one inside and one outside. You have multiple layers to arrive to the inside, and this somehow in the architecture, even in the current architecture, you don't have so much example, or at least I think about the nice example of Anne-Lacaton, where you have this winter garden, where suddenly you have the inside building and you just add another layers that allows a certain climate difference between you and let's say the real outside, which is the streets. And so how much you're thinking about this, let's say, simple possibility of saying not so much the building and then the urban climate, but somehow a building and then multiple layers to arrive to the final urban climate, which would be kind of different.
Yeah, I think you summarized perfectly the essence of our new book. I mean, this is the idea of promoting a diversity of urban microclimates. So you don't have the inside and the outside, but rather a diversity of different microclimates, for instance, with a role as a buffer zone, as in the case of Vasari-Lacaton's buildings. I think, yeah, this is a very important approach to kind of overcoming conceptually this very strongly internalized divide into inside and outside, looking rather at microclimates, and in this sense, the entire plot you would look at as an architect is the inside. So there are many different microclimates, right? But there's not this. It's also this idea of, or this notion of the city as the new indoor environment of societies, highlighting like an internal perspective and then starting to differentiate different microclimates. Yeah. Yeah.
Thank you. So as we have seen, this term of sustainable architecture, green architecture, has really been kind of co-opted as I feel like a marketing word, and all of these kind of awards for sustainable buildings, they always rely on very high-tech, normally smart solutions. However, this is kind of a standard that we as architects have to work within. So how can you kind of push for this more low-tech, or a change in the concept of what comfort is, where you don't have to have 20 degrees, 50% humidity, and maybe start to change this through your practice, but also within, let's say, the regulations of where you are working in? Have you seen maybe some examples or some instances where this has been pushed towards?
Yeah, maybe again, Vasari-Lacaton, I think they managed to find very interesting ways to push these boundaries. But in general, I think, yeah, you are completely right. And I think one approach for an architect is really to find interesting landlords and developers, so which are kind of able and interested in kind of overcoming or ignoring certain labels and maybe even standards, and then starting to find an interesting approach together with the architect. So it's very difficult, I think, for the architect alone to transform or to transcend the given standards or labels. But that's maybe one of the important strategies to overcome.
But maybe it can also be integrated with a change in policies, because now all these building regulations kind of strive for achieving these certain standards, and maybe that's creating a kind of architectural urbanism that is not actually what we should be doing.
Yeah.
Thank you.
Awesome. Sorry. You showed that house by Richard Neutra, and I'm guessing you said that it was fascinating to you for several reasons, but you didn't elaborate. I'm guessing it will be the various degrees of, let's say, inside and outsideness that he architecturally formulated, but also, if I interpreted it correctly, a little bit of a fascination for the abundance of energy that he had available and what he could do with it.
Yeah.
If we go, let's say, if we take the scenario of having to reduce CO2 emissions, and let's basically, if we have to enter a state of, let's say, austerity in relation to our previous comfort requirements, so we have to, let's say, accept a wider range of comfortable temperatures at more degrees of interference. Is there also an alternative scenario? Let's say not stupidly separating again inside and outside, but with renewable energies and let's say something like the democratization, the access to solar energy for everybody. Are there intelligent solutions also in that perspective of having, let's say, a certain abundance of energy, also by activating the sheer mass heat capacity of buildings that we have, for example, also gives us, not only makes our systems more efficient, but actually gives us a certain richness of energy suddenly. Is there, let's say, intelligent ways of dealing with that, not just reducing?
Yeah. I mean, this was Leib und Gut's idea, right? So there's this abundance of solar energy. There's simply enough energy on the world, solar-based energy, so we can build as during the Bauhaus area. So really one layer of brick, we don't have to insulate. So this, like conceptually, that would be the overall idea. But so far, we are not capable, right, to develop such high-density energy quality as in the case of fossil fuels. So I think it's a very tempting, interesting idea, but we can't work with it in general. I think only in particular areas, let's say, it's possible to do it. But maybe in the long run, in 20 years or 30 years, but I'm not sure, right? If it will be possible to really make solar energy an abundant form of energy. So far, we also have to reduce, probably, at least here in the Western countries.
But then let's see, how do we prevent the problem we have now? For example, states having, or government policies is to currently subsidize individual installation of buildings heavily with materials that we do not how to recycle even afterwards. Now we are, let's say, academically understanding the mistakes of these policies, and we have to think energy at bigger scales and not just at individually plastering polystyrene to a facade. How do we prevent, let's say, the exact same, let's say, mistake if we do not also design perspectives for potential abundance of energy, bluntly said? Or will we be able to integrate various scenarios of our energy supply within, let's say, these different degrees of inside and outside that you propose?
Yeah, I only can recommend to really experiment, right? I think you are now a new generation of architect students, and I really recommend to experiment, especially at the university. After, it's more difficult, right? You have to find the right developer or the interesting landlord to address new, or to experiment with new approaches. But my deep feeling is that we are in an age where we have to, of course, all this knowledge of the ecology movement of the 1960s and 70s is given. We have this knowledge. It's all right. We have it. We can refer to it, but it's simply not enough. We can't only deal with these kind of approaches. So in this sense, yeah, I would also experiment maybe with the abundance of solar energy in one particular project, but then in another project, I would maybe try out another strategy. So I think we don't have final answers. I would consider larger scales also, as I said. It's very challenging, it's very interesting, it needs a lot of research because nobody has the answer, you know. It's very interesting, I think, for your generation.
I think the key word in what you said there is scenarios, right? Because I mean, at the moment we're having to think about the future with so many uncertainties. One thing's for sure is that we're consuming too much at the moment. And so today we need to reduce our consumption. What that will mean tomorrow, and what kinds of modes of energy will be in place, and what kinds of technology. And we
Burning too much at the moment. Consuming, is it?
I mean, the consumption is leading us to burn too much. I mean, so at the moment we need to turn the lights off. But it's thinking about those scenarios and how the buildings you design can be flexible for that future. And somehow, you know, the buildings architects have designed have always had to be flexible, whether that be in response to climate change or to shifts in transport patterns or to shifts in family sizes. So I guess this is one new challenge that's on the table now, but there have been multiple other challenges in the past making you think with all of these uncertain futures. So I think you probably already have the skill set and the tools to be able to take that into account when designing future spaces.
So I have this one additional question I simply have to ask. So, it's perhaps we could compare energy or climate to, in terms of consumption, to food consumption, right? And it's interesting how the diet has been politicized to such an extent that we are actually discussing a shifting diet as a let's say, step toward a more sustainable future, better in terms of CO2 performance, etc., etc. So we have the Lancet diet, for instance, was most recently recommending a particular ratio between, you know, meat and protein, etc., etc., as a direction in terms of healthy eating, but also climate responsible eating, no? And so I'm curious about whether you see the potential of urban climate becoming politicized to such an extent that it would actually change practices of everyday life. And I'm thinking, for example, about the fact, something that I realized living in Singapore. We were there together at the same time. That's where we met each other. So Singapore was a huge eye-opener for me because I realized that the actual, let's say, occupation or the line of work is very determining in terms of our climatic demands. So, for instance, if I'm simply, let's say, moving around, perhaps doing some housework or even doing sports, I have not a problem at all with Singaporean climate, which is very hot and humid, as you remember. But you know, if I'm working on the computer, so if I'm in this kind of a classic sedentary office work, then I really need air conditioning, right? So okay, well, so let's see. This is so let's see the kind of how we imagine also our daily routine and our work life in terms of building performance or climate demands. Perhaps how do we teach? How do we conduct our classes? I mean, can we have classes outside? Can we move more? Can we be less sedentary in our practices, including work practices? I think that would perhaps lead to some interesting solutions. I mean, do you see any movement on the horizon in that direction? I'm quite curious.
Yeah, I mean, for me, at the end, it's again this, notion of celebrating or exploring different microclimates. So not only focusing on this global standard of having 23 degrees Celsius or so. And I think also including the urban scale means, for instance, to look more precisely how people live on an empirical level, so that how they use their urban surrounding over the course of a day, so they maybe change their place of work depending on different daytime, for instance. And I think that could also be an interesting maybe strategy for architects, talking about climate control. Climate control could also mean to change the place, right? Because it's too hot. And also exploring maybe 25 degrees as a working condition. So I did it many times. I worked at home also, and we didn't use air conditioning in the living room. So it worked quite well with cross ventilation in this case. So it's also depending on different people, how they conceive the climate, and we should more precisely also consider these kind of differences. It's not an answer.
I guess it's also related to questions of temporality as well. I mean, there's kind of capitalist work modes spread across the planet, and we expect everyone to be doing a kind of 9 till 5 job. In West Africa, where I was working, I mean, impossible to work 9 till 5. It's just far too hot. Mm-hmm. But yet these global norms put into place these expectations that one occupies time in the same manner that you would in a European city. I think there's a kind of almost like a political call for the siesta here that needs to be put into place, or a requirement to shift those working times as well around when
or for Milica, we maybe have to provide at least 2 places where she can work. In one place it's kind of comfortable in the morning hours, and then the other place in the late afternoon hours or so. So that could maybe also be an interesting strategy.
Fantastic. I like those ideas very much. Political call for a siesta, and let's say we go beyond the climate comfort. We work with the climate and organize our days and habits and routines around it. It's a very beautiful provocation. It's inspiring, and thank you. It was really inspiring lecture. Thanks, Sascha. Thank you, Alice, for being here. Thanks, everyone.